Hello guys, welcome back. So in this today's session we are going to learn about the what are the different types of forwarding techniques. Forwarding means if you want to send the packet from the one source machine to the another destination machine, so in between that we might be having the multiple routers, right? So in order to send your packet, there may be in internet we will be having the multiple routers in between your source machine to the destination machine. So now question is that how it is going to send the packet from the one router to the another router. So there we have the two types of the forwarding techniques. One is called as the next hop method, another one is called as the route method. So first we'll see about the basic method called as the route method. Once it is completed, we'll see about the next hop method scenario. If you observe here, we need to send the packet from the host A to the host B, right? Nothing but system A to the system. Now see that here we have the router 1, here we have the router 2. So the meaning here you need to understand is that when we are using the router means when you want to communicate with the one different network with the another different network, we require something called as the L3 device. That L3 device we are calling as the router. So see that for example here for each router it will be having the multiple interfaces. Suppose for example say this router might be having the 3 interfaces. So it means that each interfaces will be having the IP address mechanism. So this will be having the separate IP address, this will be having the separate IP address, this also will be having the separate IP address. So what is the use of here these 3 interfaces means which is used to connect the different network. This is used to connect the different network, this is used to connect the different network. It means that when you want to communicate from one different network with the another different network, we required the L3 device, nothing but the router. So in case of route method, what will be happen means if you observe here, my final destination should be is what? Host B should be my final destination. But here we need to tell that in which path or via how to reach to the this particular host B. In case of route method, what will be happen means each and every network device or either it may be router or it may be device, whatever it may be, it should have the complete database of the remaining network. Now currently I'm at the host A. Now see that host A should know the entire remaining network. It means that it should know about the router 1 as well as the router 2. Then one more thing, it should know about the host B also. It means that see that the final destination is the host B. Now see that currently we are at host A. So see that it should have the database of what? R1, R2, this one R1, R2, then host B. Once the packet will be routed to here, now this should have the database of the complete entire network. It means that when the packet reaches to the R1, it should have the database of what? It should have the database of the R2 as well as the host B. That is what here it is mentioned. So once the packet will reach to here, nothing but R2, now it should have the database of the entire network. It means that in this scenario, I'm going to consider this direction, right? So what is the next one to this R2 is the host B. It means that in case of the route method, each network device should have the idea about the entire network infrastructure, so that only it can able to send the packet right from the transmitter to the receiver. Now this method, if you observe here, is that suppose here I have the only 2 routers, so that I can hold the database of these 2 routers. But in case of real world scenario, suppose for example you might be having the 1000 router in between your source machine to the destination machine. So it means that each device should have the database of the 1000 router, right? So it means that here we will be having the data storage problem, something like this, right? So this is not the efficient method. So for that they have invented something called as the next hop method. So what is this means? In these techniques, the routing table, nothing but the database of the each router, it holds only the address of the next hop instead of the information about the complete route. In case of route method, it is going to learn about the complete route, how it is going to be sent. But here see that the same scenario I'm going to consider. If I want to send the packet from the host A to the host B, in earlier host A should know about the what? R1 as well as the R2 as well as the host B. But in case of the next hop method, it does not require to know about the entire network. It should only know about the what is the next hop. Next hop means where is the next exit path for this one. So see that if it is, what is the exit path here, this is right, this is what we called as the next hop address. Next hop means you can think in terms of the entry of the next router, something like this. Now see that, so my ultimate destination is what, I need to reach to the host B, right? Because why this many host B means in between this we will be having the multiple devices, right? Now see that currently I am at where, so currently I am in the host A, it means the packet will be in the host A, right? So first it does not require to know about the each and everything, so it only required to know about the what is the next router interface, nothing but this only, right? So this, if it is not R1, then what will be happen, right? So it is required to know about only next hop. Next hop here is nothing but the R1. So this is R1 is completed. It assumes that I send the packet to the R1. So hereafter R1 will take care of the remaining part. It means that the duty of the R1 is now to deliver to the host B. So like that the next hop method will be operated. Now the moment when packet reaches to the R1, now what R1 will do is it will forward the packet to the R2. This is what we called as the next hop address. Next hop address means this is the entry path for the R2. So here it will reach to the R2 by using of this entry path. Now see that what R1 will think that, so I'm going to forward the packet to the R2. Now R2 has to, right, so find out how to reach to the host B. It will not going to know about the how to reach to the host B. It will only tell that how to reach to the next hop address. The moment when it reaches to the R2, it will go to the host B. It means that instead of holding the entire database, here only it is going to store the something called as the next hop ID. Right, now see that for host B, what it required only knowing of the R1. The moment when reaches to the R1, it required only knowing of the R2. When the packet is at R2, it is not to required only about the host B is nothing but our destination, right? So in real time also we are going to use the only next hop method. So this is theoretical part. Now we'll try to understand how in real time next hop method will be implemented by using of the Cisco packet tracer simulator scenario. If you observe here, so this is one network, this network is 1.0 network. So this network is this wire V is the 2.0 network. For this connecting this router to this router to the network is 3.0. For rest of router 2 to the next interface, we have something called as the 4.0 network. For example, if you want to send the packet from where, so from the router to the something, if you want to send the packet to the PC1, we don't need to remember the entire database. Only thing is that if you can able to send the packet to this router, the rest of the things will be taken care by this router. Now see that where the packet will be leave is, what is the next hop ID is, this interface we called as the next hop ID. Suppose for example for this one, this interface I am going to give the IP address because the network is 2.0, right, something 192.168.2.1. so the moment when it is giving to the what is the next hop for this router 2, then what 2.2 means, then packet will be forwarded to this router. The same way this will be given to the next hop this router. The finally it will reaches to the corresponding destination. Suppose for example if I am clicking on this router, see that now we have the configuration. So under the configuration, now I am going to perform the manual operation. We have the two routing protocol. One is called as the static routing, another one is called as the dynamic routing. So let me, for this case I am going to use the static routing. Now see that for example, so here this is the directly connected router, right? So for this router, what is the directly connected network? Directly connected network means whichever is directly connected to this router we called as the directly connected network. It means that the router knows about this network because it is directly connected to this router. It means that it knows about the 1.0 network as well as the 2.0 network. We don't need to tell about this one because it is already directly connected. So that router will be knows by this one 1.0 as well as the 2.0. But see that the 3.0 network is not somehow directly connected to this router 0, right? So it means that we need to tell if you want to go to 3.0 network. So if you are currently your packet is here, how you can able to reach to the 3.0 network by using of the next hop method. The same way, if your destination is something 4.0 and your packet is here at the router 0. How to reach to the network? Nothing but 4.0. Here also we need to specify the next hop method. Router knows the 1.0, 2.0, so we don't need to specify. Now it does not know about the 3.0, right? Now for example, if it is want to go to something 3.0 network, right? So subnet mask we are going to give by default class C network in this case. So 255.255.0. Now now as we discussed here is that we have next hop, right? So next hop means if you want to go 3.0, this router can go via like this or via like this. If you go this one, it will reach to the 1.0, right? But where it is 3.0, after this one only we have 3.0, right? So this router having this interface, but where it has to exit, somewhere here it has to exit, right? The IP address here I have given, this exit is the 192.168.2.2. so that's what we called as the next hop address. So I'm giving the entry of the next router is nothing but the next hop router, right? So 1.2 I have given here. Now if you see that here, the same thing I have given. If you want to go to 3.0, what is the next hop? You need to go to via 2.2, right? The same way, then one more thing, it is unknown network for this router 0, right? But if you want to go to 4.0, now we need to specify, right, how it is going to go to 4.0, right? By using of the next hop method, right? Now see that if you want to go to 4.0 network, this network means how to go, because we are going to tell only next hop address. We are not going to deal about with the unknown routers. Now what it will do is it just simply forward the packet to this router 1. That is what we called as the here next hop, and it means that if you want to go to 3.0 also, you go via this interface is nothing but the 2.2. If you want to go via 4, that means if you want to go to 4.0 also, you just specify the next hop address, that is nothing but 2.2 only, you have to go to 4.0. It means that is the meaning of this one, right? So here the unknown network for this router is 3.0, 4.0, right? So see that if you want to go to 3.0 also, you go via this IP address I'm giving 2.2. If you want to go to via 4.0 also, you go via 2.2 only. Just it will hand over the packet to this router 1. This router will be having the same again like this database. So based on that, it is going to forward the packet. So let me take the packet so that you will understand. So this is my source machine. This is my destination machine. Now I am sending the packet, right? So first it is going to the L2, then it is going to the router. Now router, so where we have the destination 4.0, but the router does not know about the database of the 4.0 as well as the 3.0. Now what this router is used is something called as the next hop address. That is nothing but the entry of the next router. See that it will just forward the packet to the next router, then it will stop. The duty of this router 0 is completed. Now again router 1, what is the directly connected network for router 1? This 2.0, this 3.0, right? But it does not know anything about the 4.0, right? So now what will we do is the router will be having the next hop ID, right? So either this one or this one, right? If it is going to this path, it will reach to the 1.0. If it is going this path, it will reach to the 4.0, right? But our intention is that we need to reach to what? 4.0. Now router what will be do is it will be having the next hop ID, so that it will simply forward the packet to the router 2. Now see that what is the directly connected network for router 2? It knows already 3.0 because it is directly connected. 4.0 it is directly connected. So it means that within this network only, so it will send the direct packet delivery to the its destination through the, right? So L2 network. So after that we are going to get the reply.